In this video, we're going to go backwards from what we just learned in our previous video. So in our previous video, you were given the chemical formula of a binary ionic compound, and you were asked to write the name for it. So in this one, we're going to go backwards, where you're going to be giving the name. You're going to be given the name of that binary ionic compound, and you're going to be asked to write the chemical formula. Okay, and again, the reason that this is a little bit more challenging than our previous one, because now we have to worry about those numbers. Okay, so when we go back to what we looked at in our previous video, we saw that when we wrote the names had nothing to do with the numbers, but there are clearly on a lot of these, there are some numbers here. So when we write these chemical formulas from the names, we have to consider those numbers. Okay, and those numbers come from, remember that these are ionic compounds, and an ionic compound is a compound that is made up of ions. Okay, and ions, remember, are atoms that have gained or lost electrons. So this comes back to this row right here, remember, are called the noble gases. And the noble gases are the most stable elements on the periodic table. And atoms that are close to the noble gases will tend to lose or gain electrons so they can have the same number of electrons as one of the noble gases. For example, the group right next to the noble gases that starts with fluorine and goes down, those are called the halogens. And the halogens, if they could gain, if you look at the periodic table, if they could just gain one electron, then they would have the same number of electrons as the noble gases. And so that's what happens in a chemical reaction, is these halogens, the fluorine group elements, fluorine, chlorine, bromine, iodine, etc., they always will gain one electron. And so what we do is we put a -1 above fluorine on the periodic table. Okay, and what that does is it helps me to remember that fluorine and chlorine and bromine and iodine are always going to gain one electron to become like a noble gas. And then the group right next to fluorine is the one that starts with oxygen and sulfur and selenium, etc. That group needs to gain 2 electrons. So what charge do they always have? They always have a -2 charge. And then the next group over is the nitrogen group, and they have to gain 3 electrons. So nitrogen, phosphorus, arsenic, etc., they have a charge of -3 always. Okay, and again, all those charges mean is how many electrons does it take? How many electrons do those elements have to gain to have the same number of electrons as one of the noble gases? Now, coming back over here to the left-hand side, we've got the hydrogen, lithium group going down. And that group, instead of trying to gain electrons to get all the way over to here, that's really, really difficult. That's a lot of electrons to gain. What's easier is to lose electrons. So for lithium, it's to go backwards 1, to lose 1 electron to have the same number of electrons as helium. Okay, and sodium does it as well. Sodium loses an electron to have the same number as neon. Potassium loses 1 to become like argon. So we can see here that this first column is going to have a charge of +1. Because again, they lose. When you have a positive charge, it means you've lost electrons. And then the next group is the beryllium group, and they have to lose 2 electrons. And then remember, this whole D section, the transition metals is what we call them. We're not worried about them yet. We're going to talk about them in our next video. Okay, and then over here to the boron group, we have a +3. Okay, so we've left out some elements. I know we've left out all of these, and we've left out the whole carbon group. Don't worry about those. Okay, the carbon group tends to only share electrons. Carbon doesn't really lose electrons or gain electrons. It tends to just share them in a covalent bond. So that's why the carbon group we don't include there. And then again, transition metals, we're going to talk about that in our next video. Now, the reason that those charges are important is because, and here it is right here, the positive and the negative charges must equal each other, which means that these electrons here, or these atoms here, are going to lose a certain number of electrons. Okay? They're going to lose 1, maybe 2, maybe 3. The number of electrons they lose must equal the number of electrons that these ones here gain. So remember, these guys are gaining electrons. These guys are losing electrons. And the number of electrons lost must equal the number of electrons that are gained. Okay? So, what does that mean? It means that every time we write one of these chemical formulas, before we write it, we have to think about the charges. So I've given you the answers to these first 5, but really before we think of what's the answer, we have to think, okay, potassium has what charge? So we go to the periodic table and we find it. And it's in that first column, it's right down here. Okay, and that means that potassium always has a charge of +1. It's going to lose 1 electron. And chloride comes from chlorine, which means I go to the periodic table, I find chlorine. Chlorine is over here underneath fluorine, and it has a charge of -1. So again, what does that mean? It means that potassium is going to lose 1 electron that it would love to get rid of, because then it can have the same number of electrons as argon, a noble gas. And chlorine's going to gain 1 electron, and it can gain an electron and again have the same number of electrons as argon, a noble gas. And so potassium basically is like, look, I have an electron, I want to get rid of it. And chlorine says, yes, please, I'll take it. And since it's a 1-to-1 ratio, they basically just cancel each other out. And the chemical formula is just KCl. Okay, let's look at beryllium fluoride though. Beryllium has a +2 charge. It's right here. +2, and fluorine from fluoride has a -1, just like chlorine did. So beryllium says, I've got 2 electrons to get rid of. Fluorine's like, I can only take 1. So instead of beryllium giving both electrons to fluorine, fluorine takes 1, and then another fluorine comes along and takes the other one. Okay, so notice that our chemical formula is BeF2. Because again, beryllium has to get rid of 2 electrons, but fluorine can only take 1. See how those don't match? Okay, those charges must equal each other. So instead of +2 and -1, it's got to be +2 and -2. That's why there's 2 fluorines here. Okay, on sodium oxide, very similar. Na has a +1 charge. Oxygen has a -2 charge. Pretty similar to the last one, but sodium says I can only give away 1. And oxygen says, but I need 2. Okay, and so instead of 1 sodium, we need 2 sodiums. And then the +2 equals the -2, so we get Na2O. Okay, on magnesium nitride, you've got Mg with a +2 charge, and nitrogen has its -3 charge. And this is the only time it gets a little bit tricky, because magnesium says I can give away 2, but nitrogen says, sorry, I want 3. So you have to get to a number that they're both, you know, that what is that called? The least common multiple or something like that. Where what's the smallest number that they both go into is 6. Okay, and that's why you can see we've got 3 magnesiums. Okay, magnesium with its +2 charge. If there's 3 of them, that's a total of +6. And nitrogen, there's 2 of them, because with a -3 charge and times 2, that's -6. And again, see how now those charges are equal to each other? You have to make those charges equal to each other. Okay, and then our last one that's already done for us is barium sulfide. Barium has a +2 charge. Sulfur has a -2. Anytime they're equal to each other, they just cancel each other out. Okay, so like up here, the +1, -1, you don't have to do anything. They just cancel. +2, -2, or even +3, -3, they just cancel each other out. And in this case, you see it is just BAS. Okay, now one of the things you might have noticed here, especially on B, C, and D, is you might have noticed that if you take those charges that are up in the corner like this, and then you cross them, and you don't move the charges, you just move the numbers, notice that this 2 on beryllium came down here onto the fluorine. And even though you don't write it, the 1 from the fluorine actually came over here to the beryllium. Okay, and same with sodium oxide. On sodium oxide, the 1 from the sodium's over here, the 2 from the oxygen's here. The one time where you really see it is on magnesium nitride. Notice that the 2 from the magnesium came down here. It's on the nitrogen now, and the 3 on the nitrogen came down here. So basically you're taking those numbers and you're crisscrossing them, again, only when they're different. Remember with barium sulfide, we had that +2 and that -2, and they just cancel each other out. It's just BAS. Okay, but when those charges are different, you can take them from up in the corner and you just switch them. Okay, and then those charges will cancel every single time. Okay, so let's take a look here at these ones here on the right. So strontium arsenide, again, the first thing I'm going to do is I'm going to write strontium, and then I'm going to look at the periodic table and I'm going to find its charge. It's +2. And then arsenide comes from arsenic. It has a charge of -3. So again, whenever those charges are different from each other, like they're not both +2, -2, +3, -3, just take those numbers and we're going to switch them. Okay, so that means the formula is going to be SR3AS2. Notice I move the 2 down here and I move the 3 down here. Okay, on aluminum iodide, aluminum is +3, iodine is -1. So again, same thing, take those charges and switch them so you get Ali3. Letter H, calcium phosphide. Calcium has a +2 charge. Phosphorus has a -3 charge. Take those two again, just like our top one there, and we switch them. Ca3P2. Rubidium selenide. Rubidium is +1. Selenium, and again, I'm still glancing over at the periodic table to make sure I have the right charge. Selenium is -2. So again, we switch those, so it's Rb2Se. And notice, guys, anytime there's a 1, like right there, you don't write it, okay? It's just Rb2Se. Like on water, you don't write H2O1, okay? It's just H2O. Anytime there's 1 of something, you just write the symbol. And then our last one, lithium bromide. Lithium is +1, bromine is -1, so they just cancel each other out. So LiBr. And again, just as a reminder here, like magnesium oxide or aluminum nitride, on those, all 3 of those, here you've got a +1 and a -1, they cancel. On magnesium oxide, you've got Mg2+ and oxygen's -2. So you've got a +2 and a -2. They cancel each other out. Don't switch those. Don't go Mg2O2. Okay? It's just MgO. And with aluminum nitride, same thing. You've got Al3+ and N3-. So on that one, you want to make sure that, again, a +3 and a -3 just cancels. So it's just ALN. Okay? And that's how you write chemical formulas. That's why those numbers are now going to become important when you're writing those chemical formulas. You got to make sure that the positive charges and those negative charges cancel each other out.